Okay, now if I say the word theorem, does that sound familiar? Does it make you think of something? Have we worked with any theorems before? The theorem of Pythagoras, right? Now guys, the theorem of Pythagoras, that is basically a rule that works under certain conditions, right? What are the conditions for Pythag to work? It has to be a right angle triangle, right? Now, what we did I think you learned it in grade 8 for the first time, we didn't prove Pythagoras, right? Your teacher just kind of told you that this is how it works, and you've worked with it ever since. But for some theorems, you are going to have to prove them, all right, from now going further on. So the midpoint theorem is the first theorem that we actually have to prove. Now, just some terminology before we move on to that. They're saying an axiom is a rule accepted as true because it is self-evident, because it's obvious, right? So, for example, if A and B are equal and C and D are equal to each other, then A plus C will have to be equal to B plus D, all right? If you're just understanding the information that's given, then you can see that that is obvious, right? So imagine that A and B are both 2 and C and D are both 3, then you're going to have 2 plus 3 and 2 plus 3, so those would have to be equal to each other. All right, so that's an axiom, something that is true just because it's obvious that it's true. Okay. Definition, we've worked with definitions before. A description that defines the fundamental properties of a figure or shape. For example, a quadrilateral can be defined as, and this sounds very complicated, but it's just an example, a closed two-dimensional shape which has 4 straight sides. All right, that's just the definition of a quadrilateral. Then a theorem is a mathematical theory using known definitions and axioms, which requires a rigorous proof. Thank you. So a theorem is not always something that is just obvious. All right. If you think back to grade 8, when you saw Pythag for the first time, or when you maybe just saw a right angle triangle, it's not always just obvious to just say, okay, if you square these two sides and you add them together, you're going to get the square of the third side of the hypotenuse. All right. It's not something that is self-evident like they've described in axiom. So here they're just listing some theorems that we have worked with before. Here's a list of some of them. Angles on a straight line are supplementary. They're added to 180. That is actually a theorem which can be proved. Angles around a point added to 360. Vertically opposite angles are equal. Alternate angles between parallel lines are equal. So guys, we've just been working with these, right? But we've never actually proven that these are true. Okay. So what I want you guys to start to think about is, oh, lovely. What's happening now? Okay, there we go. The difference between proving a theorem and using it. All right, we have used all of these theorems, these 4 and Pythagoras and lots of others, without ever having to think about, okay, now I must actually prove that this is true. Okay. Yeah, let's carry on. In grade 10, for the first time, we learned formal theorem proofs. A theorem proof follows a set layout which must be followed. So guys, it's properly like book work, right? You're going to have to memorize the theorem. Sometimes you can just kind of figure it out on your own, which you are going to try and do today, but it has to follow a certain layout. So this is what you'll see when we do the proof later on. They're going to state the theorem. Okay, that will be the first thing. They'll write out, this is the theorem, this is how it works. And they'll usually give you a diagram as well to indicate it. So the statement is the hypothesis written in words. A label diagram is given. The diagram starts out as being a visual representation of the information given in the statement. So if we're thinking about Pythag, for example, the diagram that they'll give you will just be a right angle triangle with A, B, and C, for example, labeled as the vertices. Okay, nothing else, just the basic diagram. Then they'll also tell you in words what is given. They'll say, given triangle ABC, a right angle triangle with angle B equal to 90 degrees. Okay, they'll just list in words what you can see on the diagram, basically. Then there's going to be a spot or a place for you to write what you need to prove. So if we're thinking about Pythag, you would say, these two sides squared, when you add them together, is equal to the other one squared. All right, just writing out what you need to prove. Sometimes you need to do a construction, which I will show you later on. So then you have to do the construction on the diagram and you have to write it out as well. And then the last thing, the most important thing, is the actual proof written down in a series of statements, as they're saying here, in logical order with reasons given in brackets. Okay, so this is more theoretical than what we've been doing. When you are proving a theorem, you're not actually calculating something. You're not finding the length of a side or finding the size of an angle. You're proving that a theorem is true. Yes? Good morning. You can come in. I can see your slip. Thank you. 3 is what you can see on the diagram. They will write out in words. But 4 is where they actually are. You have to actually say what you're proving. So this is what's given, and this is what you have to prove. You'll see when we do an example. So if you're thinking of Pythagoras, what would be given? Just a triangle. So that's the given statement. But what's required to prove? The sum of the two sides squared is equal to the other one. So that would be the required to prove thing. Okay, so here they've actually shown an example. And guys, I don't know if you've ever thought of how you would prove this. We're not going to write this down. They're never going to ask you how to do this, but just to show you the kind of layout of what a proof would look like. They're saying here the sum of the interior angles of a triangle is 180 degrees is a theorem we have used often in grade 8 and 9, but never proven. Here is the formal proof. You do not need to learn this proof or any of the theorems that we've done so far. This is just an example to show you those steps that I spoke through now. All right, so the first thing is they state the theorem. All right, that's the very first thing. They write it out in words. The sum of the interior angles of a triangle is 180 degrees. You can see there, that is the statement or the hypothesis of the theorem. Next up, they give you a label diagram. Now, guys, the blue, right, this line is not actually part of the diagram. That would be the construction. So what would be given here is just triangle ABC. All right, that is that's the actual diagram, the label diagram. So they're saying here the diagram may be given or you may have to draw it yourself. I've never seen them asking you to draw it yourself, so don't stress about that. Okay, the diagram will always be given. If it is given, then you have to use the given letters for your proof. So if they are using on their picture, if they've drawn ABC, you can't talk about D, E, and F in your proof. Okay, I think that goes without saying. So now here, they give you the picture and then they write in words what is given in the picture. Okay, so given triangle ABC, right? What do we need to prove? What does the theorem actually state, guys? The theorem states that when you add the angles, the interior angles together, you get 180 degrees. So that is your RTP you're required to prove. Angle A plus angle B plus angle C is 180 degrees. Okay, does that make sense? That's what we need to prove in this proof. Now the construction, that might not be something that is obvious to you guys, all right? Usually with proofs, you need to memorize the construction. So in order to prove this one, what they've done is they have constructed a line here going through the top vertex, going through point A, which is parallel to the side of that triangle, all right? The opposite side. So how did they write that? Draw XY through A with XY parallel to BC. Again, you don't need to know this proof. I'm just showing you how the steps would be laid out. Okay, so now, like I said, when you're doing construction, you have to write it down and you have to do it on the picture itself. Okay, now guys, this proof is quite interesting. What they're saying here, so now this is the proof, all right? No values. They didn't give us any angle values here, all right? So a proof is like a theoretical way of proving that the theorem would always be true. So you also can't say, okay, let angle A be equal to 60 and let B, it's not working with numbers at all. Okay, so what they're saying here is, all right, they're saying here that angle YAC, right, so that angle there is equal to angle C because of alter angles, right? Are we fine with that? Then they're saying that angle XAB is equal to angle B, also alter angles. Yes? Now, if we have that angle there and that angle there, so, you know, I wish I had, I could put colors here. Let's just imagine that that one is green and this one has a blue dot. But guys, these three angles, if I add them together, would add up to 180, right? Because of angles on a straight line. Do we agree? But now I have that green one and I have that blue one there. So if the green plus purple plus blue is equal to 180 from here, then green plus purple plus blue would have to equal 180 in the triangle as well. Okay, but look at the way that it's laid out. Very formal. Each step needs to follow on to the next one with your reasons. So they're saying angle YAC is equal to C alt angles, BC parallel to XY. Angle XAB is equal to B, same reason. Then you are adding those three angles together and they equal 180 because of angles on a straight line. Therefore, now what they're doing, because we said that XAB is equal to B, right? So now here they're replacing XAB with B. We see that? These two angles are equal, right? And YAC was equal to C. So now they're just replacing YAC with C. There should be a copy there, equal to 180. And there we've proven that those three angles add up to 180 degrees. Okay, so your final line in a proof, guys, always has to be the same as your required to prove section, because that is what we're trying to get to. All right, this is what we need to prove. So this is the main layout that any mathematical proof would take on, guys. Statement, diagram, given, required to prove, construction, and then the proof. Okay, this year we are going to do 3 proofs in total. Midpoint theorem is the first one, and then when we get to circle geometry, we're going to do 2 more. Okay, which you need to know for your exams. Yes? No, that's another theorem, but you are allowed to use theorems in the proof of a theorem. Okay. Reasons, they're just saying here you get penalized if you use a theorem but do not acknowledge it by giving the reason. I think we all know that already. And you have that document that I've given you. Now just quickly, converse. The word converse you have not heard in a mathematical context before, I don't think. They're just saying the converse of a theorem is a statement of the theorem in reverse. All right, so the example that they've given here is the adjacent angles on a straight line are supplementary. All right, so that is a theorem, angles on a straight line. Now, if you reverse that theorem, that would be the converse of it. So now they're saying if the adjacent angles are supplementary, then those angles lie on a straight line. Then you can say that the outer arms of these angles form a straight line. It's basically just swapping around the order of stuff. Okay, we are going to look at it now in detail when we look at midpoint theorem. But are there any questions on just what a theorem is, what a proof represents? Yeah. That's fine. Yes. All right, let's go to our pages. I'm going to say documents. All right, guys, did you write down midpoint theorem? What did you write? Okay, let me also just make my heading quickly because I haven't done that yet. What's going on here now? Sorry, I'm getting there. So what we're going to do now is we're actually going to write down what the midpoint theorem is, and I'm going to show you just on a diagram how it works. No, it's a font. Okay, so midpoint theorem, let's write it down. In any given triangle, the line joining the midpoints of two of the sides is parallel to the third side and is going to happen here. That's quite a long theorem. We won't ask you to write it out, but we do obviously have to know it from here. So I'm just going to draw a diagram so that you can see how it works before we start talking about how to possibly prove this. The line joining the midpoints is equal to half the third side. But I'll show you now on the picture. Sorry guys, I don't want this actually to color in the shape and just okay, so you can just draw a triangle there, try and make it look not like an isosceles triangle really. And then you can just kind of estimate where the midpoint of these two sides would be. Let's see. And then we're going to do a line there connecting those two midpoints. Let's call our original triangle just A, B, C. And then we can call this line D, E. Now guys, how can I indicate on a diagram that a point is a midpoint of a line? What can I call in there? Can we put someone else? To show that D, for example, is the midpoint of AB. How can I indicate that? Yeah. Yes, I can put a line there and a line there, right? To show that AD is equal to BD. Because if these two parts are equal to each other, then D obviously would have to be the midpoint, right? And I can do the same thing on the other side, but now can I use one line on the other side as well? No, all right, because those two halves here might be the same length as the other two, but we don't know that for sure. Okay, so we need to put two lines. Now guys, what this theorem says, I'm going to fill it in blue. All right, so don't fill it in yet. But what this theorem says, let's just read through it again. In any given triangle, so triangle ABC in this case, the line joining the midpoints of two of the sides, the line joining the midpoints of two of the sides, so that would be DE, right? DE is a line joining the midpoint of this side to the midpoint of that side. So we're talking about DE here. Is parallel to the third side. What is the third side of this triangle? BC, right? So they're saying that DE will be parallel to BC. Again, don't pull that in there. And it will also be equal to half of the length. So that means that DE, the actual length of this line, will be half the length of DC. Okay. So don't fill it in on the picture. I just want you to actually maybe rather just fill it in. Fill in that parallel there, and then let's also just write it on the side here. So on the side we can write that DE is parallel to BC, and we also know that DE is going to be half the length of BC. Now guys, this is a theorem, so it does have a reason, and the reason for this is very simple. midpoint theorem. Unfortunately, we can't just write midpoint, right? That would be a different thing. This is midpoint theorem, so you have to write midpoint here. But you can abbreviate point by just writing it. Whenever you are using this, that is the reason that you would have to write that. Okay, now we're going to do the proof, guys. Are there any questions so far? Not really that much, right? We've just written down the theorem. But does that make sense, guys? That you can make this conclusion from the bit that's written down. Okay, basically what we've written down in words here, we have now stated in like a mathematical sense. Okay. So now we're going to do the proof. So let's write so now, guys, I want you to draw the same diagram again. Sorry. We are going to do a construction on it now. So I'm going to cheat. I'm just going to copy it so that you guys can go. Sorry. If you guys can just redraw that exact same diagram, please. And while you do that, I'm going to update my absentee list quickly. Yes. Okay, guys, once you draw your diagram, this is something that they'll give you. Okay, so once you to prove the midpoint theorem, they are going to write it out. I'm not going to write it out again because we have written it just up there. So write the theorem out for you. They'll give you this picture. Otherwise, they might not use the same letters. Okay, so just be aware. If they're using different letters on the triangle, so say they're calling this triangle PQR, for example, then your proof obviously needs to also work with PQ and R. Okay, so it's very important that you use the letters that they have given you. Then they are going to write out in words also what was given, even though we can't see it on the picture. Okay, so that will be the first thing that will be written down after they've given you the picture. So they'll say given. So please write this down, guys, so that we have the full proof. So they'll say given triangle ABC or whatever letters they have decided to use with D and E the midpoints of AB and AC respectively. And then what's also given is that those two midpoints are joined. So DE is joined. The wording there might be slightly different, all right, but that is the gist of it. But they've given you the triangle, they've given you the two midpoints of two of the three sides, and they've joined those two midpoints. Now, RTP required to prove. Okay, now guys, the RTP, you might have to fill this in. They might fill it in for you. All right, but basically the required to prove is what the theorem states. So what does the theorem say? If all this information is given, then DE is parallel to BC, right? And DE is half the length of BC. So that is what we have to prove. Okay, so that's going to be the required to prove part. I'm going to fill that in blue because we might have to write that down ourselves, but they might also give that bit of information. So DE parallel to BC and DE is half the length of BC, like that. No. Okay, so we start to Okay, now construction. And guys, this is something that you are going to have to fill in definitely. And also you're going to have to memorize this. This might not come naturally to you guys. You might not look at the diagram and just think, oh, obviously I have to construct that. Okay, don't expect yourself to be able to do that. So what we're going to do is we are going to extend DE. Sorry, let me do that in blue as well. Its own length, or by its own length if you want. To F. I'll show you now on the picture how that's going to look. And then we are going to join AF, FC, and BC. Okay, so guys, now what you're going to have to do for these is you're going to have to measure how long your DE is. All right, it will be different for all of us. So that line there, just use a ruler and measure that length. And then extend it by that same length. Right? And at the end of that part that you've extended, you're going to make point F. And then you're going to join all of those lines. So guys, please for construction, either do it in a different color or highlight it after you're done. Okay, because that also won't be given. That's something that you're always going to have to fill in yourself. So I'm just going to do mine quickly and then I'll show you. You want to write this in the chat. And the given part. So everything in black basically. But then the RTP you might have to do yourself as well. Okay, I'm just going to show you what mine looks like now that I've finished in my construction, which is something like that. So all the blue lines we've now added in. Okay, and point F. And guys, what kind of shape does that look like? Just quickly look at it. This shape up here is what I'm talking about, right? So this obviously is a triangle. If we've got that down. That looks like a palm, right? Now let's think if we could possibly prove that that is a palm, because we also can't just say, oh, it looks like one. So we can use that. Josh, what do you want to say? Well done. Remember, guys, what we constructed now is we extended DE by its own length to F. So we can pull in that DE and EF are the same length, right? You even measured them. You measured the length of DE and then you put that same length on it. So guys, we remember that one of the ways to prove that something is a parallelogram is by showing that the diagonals bisect each other, right? Now, if this is the quad that we're looking at, those two were given to be equal. They told us that AE was equal to E. And now we've constructed that DE is equal to EA. So we have that, guys. We have that both of these diagonals bisect each other. Okay, so that's going to be the first part of the proof. So let's just quickly write that in. Running out of space here. That's fine. Okay, so proof. So let's write down DE is equal to EF. Now guys, how do we know that DE was equal to EF? That was by our construction. So that's going to be your reason, okay? Which you haven't seen before because you haven't actually done construction. Right, so DE is equal to EF construction. And what were those other parts of the diagonals? Was it AE and EC? AE is equal to EC. Now guys, that bit of information was actually given because they told us that E was the midpoint of AC. All right, so that is given. Therefore, what is our conclusion from there? That shape, which was ADCF, is a parallelogram. Reason diagonals bisect each other. Yes. What is it? Oh, sorry, proof. I don't know why this is all right, we find out that bit, guys. We've just now proven that we have a parallelogram base. Now we just need to figure out how that helps us. Okay, so we're going back up to the diagram. I'll come back down this now. What are we trying to prove again? We're trying to prove that DE is parallel to BC. Let's think about that at first. So can everyone just take a moment and think, how does the fact that this is now a parallelogram help us to prove that DE or DX, right? You can work with part of the side or the whole side, okay, or diagonal there, is parallel to BC. We'll get to the second part of the proof as well. Okay. I'll give you guys a hint. If we're looking at AD and FC, those two will have to be equal, right? Because opposite sides of a parallelogram are equal. So AB is equal to FC, so we can fill that in so long. We'll write it down now as well. So can we now possibly prove that this bottom one, DBCF, is a parallelogram? Because if I have that, guys, then I can say that this is parallel to that. And then also DF will be equal to BC, right? Because opposite sides of the column are also equal. And since DE is half of DF, DE would have to be half of BC. Yeah, I might have lost some of you now, but it's fine. I'll write it down. We first just need to prove now that this bottom shape is also a parallelogram. So at the moment, we have one pair of opposite sides equal. That's not enough to say that it's a column, right? What else can I say here? Yes, Simon? BB is parallel to FC. Why? Yes. All right. So here, thank you. We have that AB is equal to FC. Yes. But guys, this is still a parallelogram. I'm going to make that word up. This is still a parallelogram, a palm. So we know that these two sides are also going to be parallel, right? Not just equal, but also parallel. Meaning, guys, this BB is just an extension of AB, or AB, right? So that means that AB is in fact parallel to FC, right? So we can say AB is equal to FC and AB is parallel to FC, same reason, opposite sides of palm, all right? So there we go. That's enough to prove that this is a parallelogram as well. So let's just quickly write that down before we lose our train of thought. Okay, so now we're going to say, what did we say? We said that this is a palm. So therefore, AD is equal to, it was FC or CF, and AB is parallel to FC. The reason for that is off sides of palm. So therefore, that bottom shape, which is DBCF, is a palm. No, it's not a bottom one. Now, guys, you need to be careful here. We can't use the same reason that we did up here, right? To prove the top parallelogram, we say diagonals bisect each other. For the bottom parallelogram, we have to say, what is it again? It was one pair of opposite sides, one pair of opposite sides equal and parallel. I'm actually not sure if we have used that reason before. I've mentioned it to you, but I don't think we've seen it in an example. All right, so one pair of sides parallel and equal. Okay, so guys, what I'm going to do now is I'm just going to go back up to the picture quickly. I'll come back down to this just now. I'm just going to highlight that parallelogram that we're looking at now, because that is the key basically to getting to this, to finalizing this proof. So this right there, and that, and that, and that. That is now the second column that we're looking at. We know that this shape is a parallelogram, therefore VF, but we can also just say DE, right? VF and DE, they're interchangeable when we're talking about parallel lines. So DE is definitely going to be parallel to BC because they are opposite sides of the parallelogram. And then also, guys, DF is equal to BC, but DE is half of DF. Does that make sense? So therefore, if DE is half of DF, DE would have to be half of BC. Okay, I'm going to write that all down, and then we can come back up to the picture just to look at it again. All you have to fill in is your construction. Just a construction, just a blue line. You don't have to fill in that construction. You don't have to. It's just for your understanding that I'm doing that. Therefore, DE is parallel to BC. So I'm just writing that parallel statement on its own. And DF is equal to BC, same reason. Yes, but just make sure that you do the rest of the statement. Let me just check if I write that all correct now. dx is equal to dc, but dE is half of df, so dE is half of dc now. It's from these two. So df is equal to dc. And we know that dE is half of df. So to get to that last statement, I'm basically just replacing df with df. Okay, guys, so that is a lot of writing, obviously, and a lot of things that you need to remember. And the thing with proofs is you have to follow, like what they said in that document that we read through, it has to follow a logical order, all right? So you can't, for example, leave out, maybe you forget that you have to prove that the top one is a parallelogram. So you leave that out. If you remember, oh, the bottom one is a parallelogram. I can't quite remember why, but I'm just going to write it in and hope for the best. You won't get marks for that. Okay, the proof does have to follow, each step needs to follow on from the next, or from the previous one rather. This is quite a difficult proof. It's not, yeah, not all of them are this complicated. I think it's not that bad to understand. It's just a lot of writing, right? And a lot of long reasons and a lot of this thing and this thing. I think. So yeah, I suggest that you memorize this. It's also obviously good if you understand how it works, but you are going to have to at least memorize the construction, right? That might not make logical sense to you necessarily. So the construction you have to remember, and then you just need to basically remember, okay, once I've done my construction, I must prove that this is a palm, then I must prove that this is a palm, and then I can get to my answer. All right. If you don't want to memorize every single step, you can memorize like the big steps, if that makes sense. Palm at the top, palm at the bottom, and then get to your final conclusion. Now, guys, you are only going to do this if they ask you to prove the midpoint theorem. All right? You are allowed to use the midpoint theorem without actually proving it, which we will do tomorrow. But this is just the proof. So you only write this down if they literally say, prove the theorem, that's it. All right, if there's just a question that has to do with midpoint theorem and they don't ask you to prove it, please do not write all of this down. Okay. Now I'm going to ask you to do the same proof but on a different diagram. All right, so this is going to be in your book now. So you can just write this again, the midpoint theorem proof. And now your diagram is going to look like this. I want you to write down all the same steps. Okay, so you're going to write down given, required to prove, construction, and proof. All right, obviously you're going to look at the one that we just did to guide you. And you are basically copying it, but the diagram is slightly different. The letters are also different. So the proof is going to look a little bit different. Okay, that is your work for the rest of this lesson and your homework for tomorrow. If you can still finish it now, you have about, what is it, 10 minutes. Hang on.